Hello, hello, hello. We are doing number 8.1, problem number 8. Now, we figured out our mass. We figured out our mass by stepping on a scale, and the force of gravity was pushing down on us, and I guess the normal force was pushing up, and that force of contact between us was what the scale took. Now, in my case, it was 1,100 newtons, which is my weight, and the computer did a simple calculation, and they decided that 1,100 divided by 9.8 means that I must have a mass of 108.9 kg. And I just took it for granted that that was correct. But is it? Because, yes, the forces were balanced, but this wasn't everything, because the force of gravity is pushing down, the normal force is pushing up with 1,100 newtons, but there's another force that was in play here, and that was the buoyant force. The buoyant force was pushing up. Now, that buoyant force, I'm under an ocean of air, I'm submerged under all this air, that buoyant force is pushing up, and that is also playing a factor. A part here. So, what we need to figure out is how much of an impact is that having. So, the force of gravity is equal to the normal force plus the buoyant force. Because both of those are pushing up, they're equal to the force of gravity pushing down. Forces are balanced, I'm not going anywhere. So, what is the real force of gravity? The normal force was 1,100 newtons. The buoyant force in my body, well, the formula for the buoyant force was equal to my volume times the density of the air times the force of gravity. So, and the force of gravity, of course, is my real mass times 9.8. Gravity. So, my mass times 9.8 is equal to 1,100 newtons plus my volume was 0.109 times, don't forget that decimal point there, the density of air, 1.29 times 9.8. Now, we got 9.8 showing up in a couple places here. And I'm going to divide all this by 9.8. So I put 9.8. 9.8, the 9.8's cancel, that cancels, but we've also got to divide that by 9.8. That is 108.9 plus, so, sorry, hold on, let me erase that again. Never rush, never rush. So, we got to divide this by 9.8, that's also got to be divided by 9.8. So we end up is the mass, my real mass, is equal to 1,100 divided by 9.8 is 108.9 plus 0.109 times 1.29. Let's keep going here. Mass, my real mass, is equal to what I thought was my mass plus, if I multiply these two together, I get 0.166, and so I add it up and I get that my real mass is equal to 109.066. Now that's my limit to sig figs, so I'm going to have to round this up to the tenths, so I end up with my real mass, the mass that I really have, is equal to 109.1 kg. Now, if you took me and you put me in a room and sucked all the air out, in addition to killing me, you would also get the scale to give you a reading of that. It would say, instead of saying 108.9, which it did, it would say 109.1. But is it a big difference? No. It's not a big difference at all. In fact, depending on where on the planet you took it, and the fact that the gravity is not the same everywhere on the planet, you would probably get a bigger difference than this. So yes, there's a buoyant force acting on me. Yes, I really am more massive than I thought, but it's no difference. It's no difference than, it's no bigger difference than if you took me to New York and New York's gravity is slightly stronger than LA's gravity. I mean, it's really that small of a difference. But needless to say, I still could probably stand to lose a few more kilograms. So that's that. I hope this helps. So there we are.